All right, today is December 8th, 2021. This is the meeting of the Container Storage Interface community, and on the agenda we have a couple of items, one from Deep and one from Jan. With that, let's go ahead and get started. First up is from Deep, explore, discuss feasibility of new runtime service in CSI in the context of runtime assisted. Mounts kept, navigate to README, expand, scroll down to this section. So we could go ahead and do that.
Yeah, so while that opens up, let me just go over some very quick context. The idea here is we're trying to explore are there like parts of like the mounting of the file system that can potentially be handled by the container runtime instead of a CSI plugin. So already got some really good feedback from Jan a little while back. That's that that I've kind of worked through. So in the publish path, the main idea there is like potentially doing a set of different changes to like CRI and OCI. We can make the container runtime be aware of the fact that there are certain volumes that are backed by block devices that need whose file system needs to be mounted. The CAP goes over some of the details around how capabilities and abilities can be matched. But like once the file system is mounted, there's of course like management operations from the CSI side around how the mounted file system can be operated on. And like a couple of main ones right now are getting of stats and expansion of the file system. So uh, I had a couple of conversations with like the container D folks and some of the other Signode people, and they're just not ready to kind of plumb all these through CRI and OCI right now. And there's also the fact that it's actually the CSI spec that specifies, how you obtain stats from a file system that's mounted or expand such a file system. That's the two main ones right now. So essentially, one of the ideas that I'm exploring in this CAP is, we have the two main services in CSI today, which is the controller and the node. Does it make sense to kind of explore like a runtime service that would surface these abilities? And the idea there is instead of something like a container orchestrator calling into a CSI plugin, these would actually be implemented by the runtime and surfaced also through a domain socket. Um, uh, yeah, that's kind of like the top level idea. And again, like specifically,
So Deep, I'm not following what the high level goal here is. Are we trying to move some functionality between CSI and CRI, or
right.
add a connection that doesn't currently exist? I don't get it.
Sure. So the main context for this is there are certain non-container, like non-native container runtimes like Kata and micro VM type things like Firecracker, where the container workloads potentially runs within a VM. And in those scenarios, what we have observed is if the file system mount happens within the VM environment, like within the runtimes environment, then it's it gives us certain security benefits because
Sure. Yeah, I mean, CSI was designed with ordinary container runtimes in mind, and so for the different ones, I get that it doesn't exactly do what we want. So is this alternative meant to like replace a node plugin in a context where you don't need the node plugin to do what it normally does?
it doesn't replace anything. It's more like an addition where
But I mean, like the only thing the node plugin really does is the node stage, the node publish,
correct.
and the expand.
Yes.
There's not a whole lot of stuff there, and like in the context of a VM, if I sort of imagine where this is going, what you really want is just to take a block device, get it onto the node, and then hand that off to the VM and say, okay, it's yours now.
Correct. And in that context, yeah, like the node the node plugin is still expected to say format the file system with the file system that it wants, but the actual mount of the file system will be handled by the runtime. And if this proposal goes through, and then and once it's mounted, if the runtime can indeed support more advanced operations like getting stats and expansion, the question here is like, does it make sense to surface those through like a separate service, which we expect a runtime to implement? So I call out like some of the pros of having it within CSI would be that, the expand file system and getting stats and potentially other ones in the future would also be part of the CSI spec rather than, originate somewhere else like CRI. So having these together within CSI probably makes more sense. And we can, like none of this is tied to Kubernetes in any way, and therefore any other orchestrator can potentially use them too if they want to surface such kind of functionality.
Would this tie a, I guess, a container runtime implementation to a specific driver? So if I
No.
have, okay, so basically, yeah, how would that work?
So basically, yeah, the idea is very much that that it's basically cube. So the CRI runtime class would specify, this runtime has the ability to mount like file system A, B, and C. And if the CSI plugin, like if the storage class says, yeah, for like if the runtime class can have these capabilities, then have the plugin, yield the mount to the runtime. So only when that yielding of that mount happens by the CSI plugin would kubelet talk to the runtime and say, well, instead of getting like file system mounts as part of like what you mount within the container, you get a file system mount path and a block device and file system with file system options.
But how's this going to work with all the different varieties of file systems? So one of the great things about CSI is that it basically sweeps all the details under the rug and basically says, the only thing we're going to guarantee you at the end of the day is you have a mounted file system, and how it got there, who knows, right? It could be some fuse mount, it could be block on file, it could be NFS, it could be something really wild in principle, right?
Completely.
So I guess what I'm trying to understand here is, so we're presuming other types of runtimes that maybe don't want a file system, but then what they do want starts to matter a lot, because if it's like, let's say it's like VMware and you have a block device, so you could like take an iSCSI LUN and plumb that in. You can maybe take other types of SCSI devices and plumb them through, but like there's a lot of types of CSI drivers that just won't work, right? Because they don't have a block device, or if they do, it's a weird one. What are they supposed to do? Do they just not support it? Or do they do something else?
So in that scenario, like it's pretty much up to the runtime class to specify, like, here are the things that the runtime class would support. And in case a CSI plugin needs something, fairly advanced, that's not something basic like ext4 or XFS, we expect, like, basically the KEP goes over it, but the kubelet at that point will not tell the CSI plugin that, the runtime supports these things. So would you like to yield the mount? So essentially, in those cases, it's just back to the regular CSI path where the plugin handles everything. This is mainly geared towards simple block-packed, ext4/XFS type scenarios where the runtime kernel has support for that file system and a set amount of options. And only in those cases will this kind of handover happen.
Okay, so the idea is you can always fall back to the way it works now, but like if there's a set of conditions where you can more securely plumb the volume through some hypervisor and then have the mount happen inside the hypervisor instead of, or inside the guest OS instead of on the hypervisor side, then you do this. Exactly. So it's like an optional optimization.
It's completely optional, right? And it's fully like, it's a very conservative option. Like a whole bunch of things need to match up. The runtime class, before kubelet even asks the plugin like, hey, would you like to do it? And even at
So
that point, we are saying the plugin can say, no, I don't, and like completely opt out of this.
so what would happen if someone's running some sort of a VM-based container and the plugin says, no, you just get a file system, period? Like how is that handled today? How do file systems plumb through?
So today, like in case of say Kata, there's a system called VirtIOFS, which is in charge of projecting the mounted file system like ext4 on the host up to the guest. And VirtIOFS does a pretty good job of ensuring like most of like the POSIX file system APIs are supported. And there are a handful of like fairly subtle, like very native to the file system kind of constructs that may not be supported, like very specific FSCTLs. But for the most part, it does a pretty good job. But
so it's using VirtIO FS.
Correct.
That's the one based on Plan 9.
I think it's a major improvement on Plan 9.
Yeah. But I mean, the kernel module is P9FS, right?
No, this is like VirtIOFS. That was completely weird. Like it's like very, it's like far more advanced than P9FS as far as I understand.
All right, well, I should read up on this because I still use P9FS for some weird things. If there's something better, I'll switch to it. All right.
Yeah, VirtIOFS has come a long way since P9FS, but essentially like VirtIO block with like the file system mounted on top of it within the guest environment gives you a lot better. And like
absolutely, yeah. If there's a block device that can be plumbed through, it should be. So I'm on board with that.
Right.
I don't understand how. I mean, this is going to be a huge change with a lot of complexity. It seems.
It is, yeah. I mean, in the CAP, like Ian has already called out, like what happens to FS group and SE Linux and subpath. So I have like things prepared that I'll put in the CAP for that. But this was more like, let's say if we get this published and everything else from the SIG-Node side goes okay, the day two activities, which is around file system management, which is getting the stats and expanding the file system, does like putting those things or those APIs within the CSI spec kind of makes sense.
Just from a plugin standpoint, like what changes does the plugin need to implement?
In terms of publish or?
Like, and if we are adding new CSI calls, I assume that means the plugin has to implement them. Like, what would the plugin do differently?
So the way I was thinking about it is, the kubelet knows that a file system has been mounted by the runtime. And in that case, when the entry CSI part gets an expand call or a get stats, that'll just direct it towards the runtime socket rather than reach out to the node plugin if the runtime is the one that mounted that file system. So basically, if you get a get stats or a node volume expand, kubelet knows it's in the runtime's domain, and the call would be just forwarded to the runtime, and node plugin wouldn't even play a role in those cases.
Okay, so this is more like the additions to the CSI spec are not like new APIs. It's more like more capabilities. And if you set the capability, we just won't call things.
The way I was thinking about it is this is more like a new service. So you have the controller and the runtimes and the node service today, right? With like controller APIs and node APIs. And this I was proposing more as like a runtime service, which is like a set of API that closely resembles the node APIs, but is expected to be implemented by a runtime rather than a CSI node plugin. And happy to get feedback on how else we can do this. And I know this is probably super unorthodox.
So right now the node service is required, right? Now with this, node service become optional. It will be either this runtime thing or
No,
the-
node service still will be required. Mainly because in the KEP we say that node publish will end up starting with the CSI plugin, and the CSI plugin, based on various parameters, may decide that I do not want to yield the mount to the runtime. So in that case, it falls back. It does everything. Only if the node plugin says that yes, I am willing to have the runtime manage this file system mount and post mount activities for me, then this other new service kicks in. In that, kubelet will start calling into the runtime for these things instead of going to the CSI node plugin. One of the other reasons that we are proposing this is because, like, one of the things we ran into was the runtime is like very unaware of things like pods and pod UIDs. All it knows are sandbox IDs that are provided to it through the CRI runtime. And sandbox IDs is something the kubelet knows about, so, or any container orchestrator would know about based on the constructs it's dealing with. And therefore, since kubelet has all these mappings, it can very easily do these things, as in like call into the node API with like call into the runtime API that's described here, rather than having individual CSI plugins manage this interaction with the runtimes.
Anyone object to this fundamentally, or just interested in details?
I'm still trying to wrap my head around.
Yeah, I read the cap. Like, it is complicated thing, and it will require a lot of changes everywhere, basically. And my personal opinion is that, like, it will always fall behind Kubernetes features. So when we add new feature to Kubernetes, this will need to be updated, and yeah, it will be always like late with the features, I believe. But like, technically, I think it is possible to implement it. Like, the cap is pretty solid.
Yeah, I think what I'm not clear on is if it's the runtimes that are implementing this API, why is it in the CSI spec rather than like the runtime spec?
Because right now, when user has a file system volume, then the CSI driver provides a file system, mounted file system. If I remember correctly, Deep proposes to change node stage, not to provide a file system, but a block device that gets plumped to the VM and that gets mounted by the runtime, because it's much faster than passing through a file system.
I think, yeah, the node stage changes make sense to me. I'm not clear on the other ones, like the file system one that is expected to be implemented by a runtime rather than a CSI driver.
Yeah.
Yeah, I mean, like, basically in this mode, the CSI driver is not owning the file system mount. So that's why the proposal is the kubelet or any other container orchestrator redirects those calls to the runtime, which the kubelet knows was the one that took charge of the file system. that's kind of the main reason we are saying the CO in this case talks to the runtime rather than the plugin if this handshake happened during publish.
So I've got a question. Maybe this is a stupid question. I'm still missing something. Couldn't we just like add another way of doing sort of node staging to the existing node plugin for this case, and then say like, if you go down that path, everything else is beyond CSI? Like, you know, if you want to stay within what CSI supports, you use the ordinary node stage, node publish, and if you want, and if the CSI plugin wants to advertise some capability to like do this other thing, we have some new capability and some new RPCs that you can call to create the thing that will get plumbed into this other container. And then at that point, it's not, well, I don't know, maybe we wouldn't want to totally wash our hands of it, but like you could just say like at that point, the thing that we give you, you know, you manage it through CRI, and then the details of that are specified elsewhere. And it would just be understood that if you go down that path, that you're in a different territory and different things are supported.
Yeah, the main reason I did explore that path. The main reason I felt it kind of fits in CSI is like the APIs are just like almost identical. Like instead of volume IDs, kubelet is mapping them to say run the sandbox IDs that it knows about. That's kind of like one aspect, but other than that, the APIs are identical, like, you know, get file system stats for this volume, either from the node plugin or from the runtime. Same with expand volume, either from the plugin or the runtime. And let's say later on, if we add something like, you know, Quest or file system for snapshots, like having it within CSI kind of makes you aware from the get-go that, you know, this is something that the runtime may need to be involved with as well. So it's kind of like,
I guess does that mean if like we need to get runtime representation in our meetings and our API reviews? I just wonder if it's adding, even though like the APIs are going to be the same, it's like different groups that are responsible for implementing it.
Well, so as a CSI plugin writer, like, is this new type of a what are we calling it? A new service, something that I would write to for if I wanted to support this feature, and then that service would run like inside the guest OS, in addition to the node plugin running on the hypervisor and the controller plugin running wherever it runs?
So I'm expecting the new service will be implemented mainly by the runtime, and in the Kubernetes context, something like the runtime class can surface like, you know, here's the domain socket, kubelet context.
So as a storage vendor, there's no code for me to write for the runtime service. That's someone else's job.
Exactly. Like we would expect Kata, for example, to implement this service.
But then it feels like a lot less valuable to have it be part of CSI, because isn't part of CSI a way of sort of telling storage vendors like, this is what you need to write for it to work, and then everything else is Kubernetes' problem or the CO's problem, whatever the CO is. Like if this new service is not something that storage vendors have to deal with, why make it part of CSI? I mean, maybe it needs some kind of home somewhere and there's no other obvious place to put it, but I don't know. I guess I look at CSI as like, you know, this is the interface that you need to implement if you want your storage device to just work in Kubernetes. And all this other stuff doesn't feel like it's part of that.
Like the storage vendor themselves will not be implementing this.
Right. I mean, well, they might implement like the one call that like is like a different flavor of node stage that gives you a thing that you can plumb through directly into the container runtime. Like, but that's where their responsibility would end, right? They would say, yes, I support it. I'm going to implement one new RPC to do that work, and then at that point, it's someone else's problem. I mean, the Kubernetes would still have to deal with it, and CRI would still have to deal with it, and whoever writes that node, that runtime service would have to deal with it. But the storage vendor would say, "I've done my work by making this block device available."
Agree.
And that could make it sort of relatively simple, because like, yeah, you know, if iSCSI is something that works, I could easily imagine adding some new RPC that says, I just want to take, it's going to be a file system volume, but all I want the CSI plugin to do is to make the underlying block device available, and maybe put a file system on it or whatever, and then hand that off to someone else, and then the reverse of it at an unstage, and then, but that's all I have to write.
Exactly.
That doesn't feel bad to me, and that feels like it's fairly straightforward to just add that to CSI, and then keep all the complexity somewhere else.
Yeah, I mean, in that case, I know that that's not a CSI discussion per se, but like if we follow that path, then we'll potentially have to come up with some other kind of interface
Yeah,
for.
yeah, because there's a weird three-way relationship between the container orchestrator, the container runtime, and this thing. I get that.
Yeah, I mean, completely agree. It's storage related, but it'll be implemented by the runtime. So therefore, totally appreciate the pushback from CSI against this. If that is a recommendation, would someone have any recommendation of where we can explore that? Maybe like what is that other API? Like, would that be a SIG Arch type thing, or?
There is
mean,
something called a container device interface. I'm not sure if.
Yeah,
It's
it feels like a CRI thing, but I don't know enough about the details of CRI to say if that's true or not, because I don't go to those meetings.
Right. Yeah, I did sense a bit of pushback from there as well, because they felt like this is more like a storage type thing. I know Jan kind of also echoed the same, like, hey, what does Signode think about this, right? Yeah, so I mean, if it's a SIG-Arch thing, then I can totally, go there and ask, but I'm just looking for some guidance that, if we don't want to host in CSI, where might be the next place we can look at, or
well,
you might want to take a look of the
certainly,
container device interface thing. I'm not sure if it just came to your mind. They actually talked to Signode. They actually have a repo. I don't know if this would fit, but maybe you can take a look.
Yeah, so I did talk about the container device with Pat Foley. He took a look at it, so there wasn't a lot of alignment there.
Okay.
Unfortunately, so I think their probably aims are a little different. So Patrick is one of the reviewers from the CAP as well. So
because they are also trying to do something that is like almost like a duplicate of CSI. So that's why I was thinking.
That's not so good. What I was going to say is, no matter what, at least part of it does have to go into CSI. Like, there does have to be a new capability and a way of saying, I want to stage a volume for this express purpose of just handing off the block device to someone. So like that is a CSI thing for sure. But then all of the other stuff, like the runtime service itself and how it works and how you talk to it, feels like, I mean, maybe this is something that just needs to have lots of different pieces in lots of different places, and
it does, yeah.
And maybe there's no place to put the nucleus that holds it all together.
Yeah, it's almost like CRSI in my mind. Like runtime with some storage stuff. It's a high, so yeah.
Maybe a stupid question. There will be some core somewhere, probably in CRI, that is able to mount volumes. And that thing is not very different from resizing volumes. So why should we split those into separate interfaces? It should be in the same interface.
Well, the CRI interface is more like run a sandbox, create a sandbox, and run a container.
Yeah, but it needs to mount volumes. It needs to tell the sandbox to mount something.
Correct.
So using the same interface, it should be able to tell to the sandbox to the VM to resize this thing. Also.
Yeah, so that's basically yeah, today it's the say the the run container or the start container interfaces in CRI that has the mount information within it. And for regular containers, it's just like two mount paths, right? One in the container and one in the guest in the host. And CRI just does a bind mount or sets up what IFS in case of Kata. Embedded within the run container thing. So one option could be to extend CRI if we were to do it and say, get me.
Yeah.
I mean, having done a lot of CSI plugins, things like resizing are very, I'm going to echo what Jan's saying. They're very tied closely to the mounting process, because what I typically do is just do a gratuitous resize on every mount. And that solves a lot of issues related to resize. So like anything that does mounting probably also needs to be able to do resizing.
Exactly.
Because that's just the right way to do it. And then of course you also need a way to say, if it's already mounted and you want to do a dynamic resize, then yeah, you need another sort of call to do that, which we have in CSI and it works fine.
Exactly, that's the one.
But I mean, but those are tied together, right? Like there's a resize is needed at mount time and there's a resize is needed after mount time. You can't do one without the other and get useful results.
Yeah, so the resize at mount time fits pretty cleanly, right? It's something the plugin can handle. It's the dynamic online resize after the thing is mounted where
but the thing that does the mounting has to handle it, which today is CSI, but in this proposed world, it could be the CRI that's doing the mounting, and then the CRI has to own the resizing too.
Correct.
if it wants to own that.
I think we're putting Deep in a little bit of a tough spot where SigNode is saying no and go to talk to Sig Storage, and Storage is saying go talk to SigNode. Sounds like Sig architecture is probably a good one to go to next and see what they think.
Okay.
Well, I'm not saying Sig Storage shouldn't own something. I'm saying that CSI doesn't feel like the place to put it, or to put all of it.
Are
right?
you suggesting, Ben, basically like another net new interface somewhere?
Well, someone said something about CRSI, or I don't know. That sounds kind of like a weird acronym, but like, yeah, we may need something that sits alongside CSI. It does feel like something that storage SIG in general cares about, but I see CSI as being very storage vendor focused, right? It's when the storage vendor shows up and says, what do I do to be compatible with Kubernetes? We say, go read the CSI spec and go implement that. And then they say, okay. And it's worked well for something like 100 different drivers, right? This just feels like it would confuse that.
It could be part of CRI that's kind of maintained by Sig Storage. I can imagine something like that.
Yeah, that may become unavoidable, because I made noises a couple months ago about the problems we have with with UIDs and GIDs in the mounted file system, and I proposed what we really need is sort of UID shifting mounts to be implemented, but that's not something CSI can do. It's something CRI would have to do. And so that there are other concerns that we have related to storage and the CRI, and maybe it's inevitable that we have to talk more and own something that interacts there. I've never really delved into exactly what goes on in the CRI because I've been too busy, but there could be a several reasons why we need to talk more and interact more closely.
Yeah, that's totally fair. So I guess as next steps, maybe I'll try to find out some slot in Sig Arch and try to have a discussion around this and kind of go with guidance I get there and kind of follow back if there's something on CSI.
That sounds good.
Cool. Thanks, Lad. Appreciate the
Cool. Thank you, Deep. This is a big effort. Thank you for driving it.
Sure.
All right, next up, yawn, force detach of volume. CSI says controller unpublished must be called after all node state unstage volume and node unpublished volume on the volume are called and succeed. Some COs call controller unpublished without node unpublished stage in order to detach a volume from failed nodes. Do we want to make this official? This is just initial brainstorming to be turned into a PR issue later. Anything you want to add to that, Young?
Not really. Like maybe the way we detach volumes in Kubernetes is kind of odd, but we will sort it out in Kubernetes, I believe. So in this call, like I would like to get agreement if we want to have some force detach or something like that allowed in CSI, if we, for example, need a new capability for that.
So Jan, can I ask if you're familiar with the PR that I wrote several months back for force detach?
I'm sorry, I'm not.
Okay. So I was going to say this is exactly what I proposed a while back. It was a fairly substantial change to allow force detach to happen that would have involved a capability or a couple of new capabilities on the plugin side, and a very specific amendment to the state change diagram that said if you have this capability, then you're allowed to do these other state changes and go directly from what the node published to the controller and call controller unpublished from there, and you go into this funny state. But I got pushback on it, and I decided not to continue pursuing the CSI spec change and just do a proprietary version of it. But the PR is still there with all the proposed state changes, and maybe it does what you want.
Yeah, maybe I will check that.
Yeah, let me dig up the PR.
Yeah,
that one has very big objections from James. That's
right. James didn't like all the additional responsibilities that it places on the CO. And it's undeniable that to do this right means there's a lot of work for the CO to do, but it sounds like we're doing some of that anyways in Kubernetes, and we're just taking it in tiny little bite-sized chunks instead of doing all of the work and just doing it right from the beginning. And I'm not on board with that, but I'm not doing the work, so I can't complain too much. Okay, it's PR 477. Let me put it in here. Come on, it's not. Wait, what? My browser just blew up.
Yeah, at one point I also incorporated that into the non-graceful no shutdown, right? And then James did not like that. I think he had a lot of comments there. So we ended up removing those. Yeah.
There we are. Okay, I put it in the notes. Yeah, PR 477. And if you look, like there's a big part of this change is, wait a minute. Trying to find it now.
Jesus.
There's a whole bunch of ASCII art changes to the diagram. That basically do what you're talking about, saying, you know, if you have this capability, you can. There, yeah, I see it now. Yeah, it's a big PR because of the changes to the diagrams. But yeah, I think that in the long run, we need a way for the CO to break out of the existing limitations of the CSI state machine and say you can go straight from volume published all the way back to unpublished on the controller. And then and the problem is, of course, that means the node is in this weird undefined state and needs to be cleaned up. And most of the rest of the work in this PR is about automating that cleanup work. So I know that on the SIG storage side, we've talked about, you know, well, let's only address the cases where there is no node cleanup work to be done, because either we can be sure that the node is really dead, or we can be sure that we're going to reboot it and that no cleanup is necessary. And so that's a nice optimization to get around having to clean up the node. But my proposal
I think James, I think his objection is because he said in some bare metal cases, you have to reboot to clean up. There's no way around it. And also even Hermand also have the same opinion. That's why we decided to not to go that route. And then
I don't agree. I think
but I'm just saying they do have objections, and I don't have any other reason to say they are wrong, because I don't really have any like test bed to say, okay.
So the difference between bare metal and a VM is that with a VM you can of course just reboot it, right?
The problem, of course, is the Ben. You have your test bed, you have a certain system environment you can test with. I have something, but we are not covering everything. So, and then James and Herman says, in certain cases you do have to do this. And then Herman also said there is some documentation from AWS said, even says that you do have to reboot. You have to reboot. It's documented. So yeah.
Right. So that could be a particular CSI plugin cannot clean up without rebooting, and it could just not have the capability, in which case you would not be able to use this particular way of doing a force detach with automated cleanup. But if the plugin says I can do it, then there's no reason to force the reboot. You could say, oh, okay, this plugin knows how to go clean up its force detached volumes, and so just make the appropriate calls and skip the reboot and allow the workloads that were running on that node that didn't have any storage to proceed. But because the issue is always you're going to have a node with a bunch of different workloads on it, some of which have volumes and some don't. It's going to fall out of what's the word? Quorum. It's going to fall out of quorum. Kubernetes is going to make a bunch of decisions about the workloads, and then when the node shows up again and says, hey, by the way, I never died, I was running the whole time, Kubernetes should be able to figure out on a per workload basis, what should we do? Should we let some of them live? Should we kill some of them? Should we clean up some of the volumes that were attached to the workloads that we did force detach? You should be able to go through and fix all of them. And rebooting isn't an automatic thing, right? Under normal circumstances, if you have a node with no volumes that comes back in, kubelet will just clean up and delete all the pods that it's supposed to delete, and it's say, I'm ready for new workloads, and it'll continue. So that it can work without a reboot.
Right. What they are not saying there's not possible to do. They are just saying there are cases it's not possible. So maybe we can bring them back and here and have another, in our other meeting and ask them if it's okay, we proceed with this, but just to say these are the capabilities. You can opt out if you don't want to do it.
Right. I would say to the AWS guys, like, just don't implement that capability, and then the workaround would be if the CO detects a situation where it wants to force detach volumes and the SP can't do cleanup, then you're obligated to just trigger a reboot before you allow the node to take on any new workloads, and say that's your way of cleaning up.
I can see like this new elaborate PR that adds a lot of states and such. I would like to point out that
so the PR is not as big as it looks. I want to.
Yeah, I know.
It's 2 new capabilities, a few new Boolean arguments, and then a bunch of ASCII art. That's what the PR is.
Yeah, I see. I would like to point out that Kubernetes right now force detaches volumes. We have it implemented, it happens.
Well, basically, Yang, you are saying that maybe we should look at our spec and maybe we need to relax language since we're doing that already.
Yeah, that was one of my suggestions.
Mm.
I was thinking about new capability. I will read the PR, definitely. But I don't want to grow it. Like, it should be a fairly small thing. Do I support for detach? Yes, no.
So what you're going to add something like maybe if there are failed node, that's the time that you are allowed to do this out of order. What are you trying to add?
again, a flag or capability, do I support force detach or not? And the external attacher can do the right thing then.
So you're saying that we don't really want to add anything, just capability, but we don't really need to add anything else in
Maybe.
the
Like,
driver
because
implementation.
As long as we're clear that like under this the only circumstances under which you would call controller unpublish before calling node unstaged, node unpublish is when a reboot had happened or something. I think you could get away with that.
So then, yeah, then we also need to have that CSI driver capability added back. I mean, not capability, the flag added back, right? Because we can't check the capability directly in those places.
Probably.
So because, yeah, so the, well, so not everybody here were in the CSI implementation meeting. We talked about the non-graceful no shutdown cap, trying to narrow that down. So basically we would require a reboot. So the user will either know that it's already rebooted, it's shut down. So add a quarantine annotation to that node, or a cloud provider. We would cloud provider already has this.
No. What I'm suggesting is if the driver doesn't support force detach, it would break the node, then we will never force detach. That's what I'm suggesting.
Right. So what I'm trying to say is in that when we're talking about that, there was actually originally there is a safe detach flag, but in last meeting we decided to get rid of that. So if you do not agree, I hope Jean is not here in this meeting. Well, actually, we have the meeting next right after this, right?
Yeah.
We can continue, right? So because in last meeting, like both Jean, Hamar, you also in that meeting, right? The opinion was like it's really don't really need to have that flag. So so I basically updated the cabinet and removed that. If you think we really need to have that flag, and in addition, you think we also need to have a flag in CSI spec, then we can add that back. And just note that the cap right now is narrowed down, so we require a shutdown to happen. So it's not going to be like if it's a node partition, that's not covered basically. So that's why that's the reason why that flag was removed. But if you still think we should add it back, I'm fine. I just want to make sure everybody is on board and we're not like adding it back and forth.
I think it will be a different cap because my use case has nothing to do with shutdown or reboot.
Okay, so you're saying it's basically
right
it's a network partition.
No.
What is this?
Kubernetes force detaches volumes right now. In every single cluster, I can make Kubernetes force detach volumes. Okay. And CSI doesn't support that. And sometimes it breaks a node for special CSI drivers. Well, not special, they are not that special. So I want to give the CSI drivers opportunity to opt out from this force detach somehow. I don't want to break the nodes. It has nothing to do with node shutdown. It has nothing to do with network partitions. It's completely orthogonal.
So where are the places that you're checking this capability? Is it in the kubelet or is it in the attached controller?
I think I know what Jan's talking about. This is the 6-minute timer that if you haven't, that if the container appears to be dead, it just force detaches it even though the node plugin wasn't doing its job, right?
That's the attached detach controller.
Yeah.
Yeah, so we've actually been seeing a bit of this stuff too. Like, for example, if you have problems with your disk control plane and the attaches or detaches are slow, like say you're out of API quota, then it can take a super long time for things to detach. And yeah, you'll hit this 6-minute timer.
So if you're adding this spec, and if you are also adding the safe detach flag in CSI driver, then I think we should still use it in MyCap, the non-graceful node shutdown, because it's going through the same code path.
Right,
We should check the flag as well.
But the issue here is that Kubernetes existing behavior violates the existing spec, and we're trying to.
That's fine. I'm just saying, like, if we're adding the spec, then we should also check this.
We're trying to clarify the situation and get back to a state where we're not in violation, right?
Right, but in that type, we're also there's one place where also allow the detach to happen, allow volume attachment to be deleted.
Like
Kind of
maybe we
out
will
of
come
order
to the
as
same
well.
solution, but at least in my case, we have some options. Like we could add, I don't know, parameter to external attacher. We could add parameter here and there, not to force detach. But
how could we do it on the external attacher? I'm just curious, because
like
it's ADC that's the problem, right?
External attacher external attacher can know if the volume is mounted. If node unpublished didn't succeed, it can know that. We have it in the API, so we could the external attacher could check that before calling detach.
But I thought
but anyway,
it doesn't.
that's the Kubernetes side. I wanted to fix the CSI side first. So I see there is a PR to add some force detach. I will read it. I will check if it is useful, if it is the thing what I need, and maybe we can make a meeting about that again.
Okay.
The Kubernetes side will follow, I would say. And like on Kubernetes side, we have other options. We are breaking CSI already, so well, we can break it even more.
So Jan, if you have any questions or suggestions about this PR, please, after you read it, please reach out to me, because I haven't totally given up on this. I'm just doing it out of tree because I don't see any other way to make progress on it within the community.
Okay, thank you.
All right, anything else in terms of topics for discussion or anything else on this one? All right, we'll call it a day then. Thank you, folks. Take care.
Thank you.
Thank
Bye.
you.